First off, we're going to power on the oscilloscope and reset it to its factory default. This is easily done by holding down the user button and then powering the instrument on. You'll hear two beeps indicating that the instrument is in default mode. We do this to make sure we're in the auto connect and view mode, which will allow us to move quickly from test point to test point to acquire waveforms and display them on the screen. In our first scenario, using the demo board, think of yourself as a maintenance technician. You've been called out to a malfunctioning machine or controller. Production is backing up, and the operations manager is anxious about getting things moving. So as the maintenance technician, what are you going to do to troubleshoot the faulty device? After checking for any obvious physical damage, you'll want to take a look at the circuit at a high level, looking at key test points. Typically, you're looking at the input signal, the output control signals, the power supplies, and any feedback or interlock signals that might be causing the malfunction. You'll be checking for any missing signals and looking at the quality of the signals, checking for anything obvious that could point you to a problem on any part of the circuit. First, you're going to connect the scope meter reference lead to the ground plane. Then you can move from test point to test point, looking at each of the critical test points for signs of failure. Here, I'm probing on the DC bus negative or low signal, looking for any signs of distortion or dropout of the signal. Moving to the DC high signal, again, inspecting for any potential problems on the DC signal. Next, we'll move over to the inverter circuit, looking at the fast-switching electronic gate. Looking at the gate signals, the output pulses, and the high-frequency pulses, again, we're looking for any signs of distortion or transients that may be causing a malfunction on the output of the switch. After inspecting the switch, we can move to the three-phase output signals, looking at the sine wave for any distortion. Looking at phase A, to phase B, and then to phase C. By using Connect and View, you can quickly move from test point to test point, looking for obvious signs of failure without touching a single button on the oscilloscope.